This video is going to go over Unit 7, Lesson 3, Connecting Inverses and Composition. So we talked about in Lesson 2, Part 1, how to tell if two graphs are inverses of each other by looking at the graph and checking to see if they reflect over the y equals x line. So there's another way to check if two functions are inverses, and that is to see if the composition of those functions equals x, which is what this first or the second bullet point right here says. We are looking at whether or not f of g of x equals x and g of f of x equals x. And so you have to verify that both work. And so, for example, in example 1, it says verify that f of x equals 3x minus 5 and g of x equals x plus 5 over 3 are inverse functions. So we're going to start by doing the composition of f of g of x, which means that I'm going to rewrite function f. I'm going to plug function g into it. And then I'm going to simplify and add like terms. And so what we see here is we have 3 times x plus 5 over 3. Well, since we're multiplying a fraction with a denominator of 3 by 3, these 3's are actually going to cancel each other out. So we're left with x plus 5 minus 5. Well, x plus 5 minus 5 is just x. So far we are good to go. If you got something other than x, I would check your work, but then if it is not equal to x, you can quickly say these functions are not inverses. So in order to say that they are inverses, we have to do g of f of x. So I'm going to rewrite g, but in place of x, I'm going to put a set of parentheses, 3x minus 5. So I have 3x minus 5 plus 5 on top, and so those 5's are going to cancel each other out. So I have 3x over 3. The 3's are going to cancel each other out, so I'm left with just x. So since both f of g of x and g of f of x equals x, then yes, these are functions. Now, if you just simply wrote yes and you did not show any work, that would be a problem. So you do need to make sure that you're showing work. One other way to show this, I'm going to give myself a little bit more room here. If you, this is just a second approach at this type of problem. If you want to start with f of x is y equals 3x minus 5, flip-flop the x and y and solve for y, just simply finding the inverse as we did in lesson 2. I would add my 5. So I have x plus 5 equals 3y, divide by 3. I can see that the inverse of f of x, remember this is f of x, is the function that we get in g of x. And so since they are inverses of each other in both approaches, either set of work would work, either the red or the blue. All right, let's do a couple more examples. So I'm simply going to do composition from now on, but if you prefer the blue method, you can rewind a little bit and look at that again if you want. You can certainly go that route. All right, so for example 2a, we are going to see if these two functions are inverses. Once again, I'm going to do the composition route. So I'm going to do f of g of x. So I'm rewriting function f, and I'm plugging in function g. So when we are multiplying by 1/4, it is the same as dividing by 4. So I'm going to distribute that 1/4. 1/4 times 4 is just 1, so I'm going to put 1x or just x. 1/4 times negative 16 is negative 4, and then I have my plus 4. And this negative 4 and plus 4 cancel each other out, so I'm left with 1x or just x. So far we're on the right track. I'm going to do g of f of x. So 4 parentheses, I'm rewriting g. I'm going to plug f in. So I'm going to multiply by 4. 4 times 1/4 is 1, and 4 times 4 is 16. And then my 16 minus 16 cancels, and I'm left with just x. So they are inverses of each other. Okay, so let's go ahead and do another one. Eventually we'll get to one that's not inverses. So let's go ahead and do f of x, or f of g of x. Anytime you're checking to see if they're inverses, just jump right there. Rewrite f. I'm going to plug g in. I'm going to distribute that 3, add my like terms, so negative 9x plus 27 minus 9. So then when I add my like terms, which are these guys, I have negative 9x plus 18. Since after I simplified, I did not get simply x, we can automatically say, no, these are not inverses of each other. And I should have put a yes at the one above, because they were. So you don't have to do both sets. If one of them does not work, you can go ahead and say, nope, they're not inverses of each other. Let's check C. So f of g of x, I'm going to rewrite function f. Putting in a set of parentheses, I'm going to fill those parentheses with g of x. So the first thing I notice is that my exponent, 3, cancels out that cube root. So I'm left with 1/2 times 2x plus 4 minus 2. I'm going to distribute that 1/2, which is the same as dividing by 2. So 1/2 times 2 is 1, and 4 times 1/2 is 2. And then I add my like terms, 2 and negative 2, and I'm left with just 1x. I'm going to do the same thing for g of x, or g of f of x, sorry. Rewrite function g, plug in function f. So this one's kind of weird to simplify. I'm going to start by distributing that 2 inside, and that cube root's going to be the very last thing I do. So I have, this will be 1x cubed minus 4 plus 4. I'm going to add my like terms inside, so then I'm just left with the cube root of 1x cubed, or x cubed, which is just x. So since both of those equal yes, x, I can put yes, these two are inverses. Now in that last one, that one's kind of tricky. So you could go the other route and start by trying to find the inverse of f of x. So I'm going to put y equals 1/2 x cubed minus 2, flip my x and y. There we go. So x equals 1/2 y cubed minus 2. I'm going to add 2 to both sides. And to undo that 1/2, I'm going to multiply both sides by 2. So I distribute that. We have 2x plus 4 equals y cubed, because those 1/2s and that 2 canceled. And then I'm going to cube root both sides. And so my inverse is the cube root of 2x plus 4. So I started with with f of x, and I ended up with g of x, and so they are inverses of each other. Just two different ways to approach that problem.